Assalamualaikum, my name is Elisa Afira and my car metric number is AE190067. So based on this low voltage switchboard in the left side, this is the digital, and at the right side is the analog meter. Consists of ammeter, voltmeter, which have their selector switch to select scale, and power factor meter. All the meters are to measure voltage, current, and power factor through the switchboard. At the bottom of the meters, there's three indicating lights to monitor and alarm the operation status of this LVSP. Next are the circuit breaker. The air circuit breaker is to provide overcurrent and short circuit protection for electric circuit overhead 8 amps to 10 kiloamps. This usually used in low voltage application below 550 volt. Beside a circuit breaker has a earth fault relay to operate leakage currents to earth, and then earth leakage relay is for residual current protection for all level of low voltage installation. Kilowatt hour meter is to measure the consumed energy flowing through a circuit as a standard 240 VAC line in a real time. Current transformer 150 to 155 amp is the maximum current, or the incoming current is 150 amp, and step down by these cities to 5 amp. Inside this LVSB, there is one heater as the supply heat because the switchboard is placed in the cool temperature. IDMTL, or as known as overcurrent and earth fault relay, is to see the line currents does not exceed the safe values, and if it does, trigger the circuit breaker. So as the current keep increases, the relay takes minutes time to trip the current. Electronic surge protection is to protect device from surge. They use a specialized circuit that redirects spike of electricity right into the ground without going through the electrical device. And last but not least, the bus bar. The existence of this bus bar is to distribute energy from the incoming TMV to users. Thank you.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Right now I will explain about the figure of 7.3 schematic controlling for main incoming. So first, we need to know where we will start to read this schematic diagram. First, we need to look for the incoming. We will start for the incoming TMB, which from below, this below. And from at the top is the main bus bar. Okay. After that, incoming supply is from the underground. That's why it's from the below. And you will go to the top, to the main bus bar. Incoming TMB will go into the load. This is the main bus bar. We start our analysis schematic diagram. From the incoming supply to the main bus bar. Okay. At here it mentioned for the 4.5 volts and 240 volts, 3 phase and 50 Hz AC supply. So this incoming is AC supply and 3 phase. Coming from the MD is 4.5 volts, and the outgoing is 240 volts. So this is the three phase step down to the single phase. Okay. We can check the diagram if you want to confirm that this diagram is 3 phase. At here we can see it has 4 lines with the color of line is red, yellow, blue. Okay, and the last one is a neutral line. The red line, yellow, blue, and E for neutral. You can see this E, this B for blue, this Y for yellow line, this R is for red line. Okay. This all line is connected to the kilowatt meter. This is a kilowatt meter, all of it. So, before I come in, it will connect to the kilowatt meter. So, then we have MCB module. This is MCB module. MCB is module circuit breaker. This one are for wall protection. Then we have main supply indicator. Where is main? This is a main supply indicator. This one. This is main supply indicator. Indicator have red, yellow, blue, and incoming from TMB can be seen in the main supply. Is from this here. When come in, we can see to this main supply. Okay, once we energize the red, yellow, blue line will function. This red, this yellow and blue will function. It will shine for the color shine. Then we go. Before that, I remember that there is the CTS, which means is the current transformer, and it have 3 units. Its ratio is 155.8, and each stage is have 3 units. So all these units will go to the kilowatt meter, the relay, and the current emitter. Where is the current? This current emitter. Okay. And then we connect to the PR control. This is the PR control. Wherever have CT, wherever have CT, it will connect to the relay. This one is relay. When they connect to the relay, it must step down to fast end. Okay, then we go to the heater. You can see the heater at here. It is to control for not to moisture and overheat. You can see the SCB TPN. Where is the SCB? SCB TPN. You can see here. This is SCB TPN, which means air circuit breaker, 3-phase. It connects to the relay. This relay will give signal to the SCB to open circuit. Make sure relay operates very well. The rated can just see at the single line diagram. We have AS selector switch, which means emitter selector. This is AS, and this is for VS, voltage selector. Its function is to select the red value, yellow value, blue value, because it is analog. Also goes same to the voltage selector. Its function is same too. And last one, we have bus bar supply at here, and it is near going to the load. Okay, that's all from me. Thank you.
Assalamualaikum. I'm going to explain the schematic control diagram for outgoing feeder for relay EFR. So this for relay, this circuit already simplifies it from the main. So we know from the main, this 2 PR control, power traction relay, rotation relay. They connect to the from the connect this 10P10 15 VA CTS. So how we know is 10P10, the meaning the P is the protection, and the connection is we have the four wire connect it. So this 3 OC overcurrent and 3 overcurrent and 1 EF fault. So this all it connect to the protection our relay. So back to the simplest one. So we start from the main bus bar. We start it from here. Okay, and then I'm going to explain the circuit breaker 100A TPN MCCB. So this the type of the circuit breaker is MCCB, and it connect to the shunt trip coil ST, and then it connect to the coil mechanical contact is normally open. This coil is for the protection. Yes, it's normally open, and when it close, so the meaning when it close is a fault is happen. When the fault is happen, it close, it gives signal to the shunt trip coil, and shunt trip coil give the signal to the circuit breaker. So when the circuit breaker get the signal, it open this wire. Okay, for the CT, we have one primary and 4 secondary. Okay, so the maximum for the current through this wire is the 5 A, and also the range for this a picture of the EFR. So the range the current is the 5 A, and this number 2 and 7, if you open this EFR, you can know the wiring is correct or not. We refer from the circuit. So we follow the wire has the label too, F2 and 7. Okay, and then this one is connect to from the red wire. So this, if you follow wiring, so it connect to the red wire, and 8 it connect to the neutral wire. Okay, so that's all for the EFR. And okay, next I will explain the earth leakage relay. So the earth leakage relay, they are not different with the EFRs. The different, but they are slightly different, which is the CT. So as you see, EFR is use the CT, and for the leakage, it use the ZCT, zero current transformer. So the connection the ZCT is by they clamp the red, yellow, blue and neutral. So it clamp. So this a connection cable. So you tap in the 1 and 2, and then you tap in the 12, and this are normally open, and tap in 10 connect to the ST shunt trip coil. So shunt trip coil connect to the circuit breaker MCCB. So after that 7 and 9 used for the energize the relay. Okay, the 7 tapping to the neutral, and 9 tapping to the red cable. So that's all for the leakage relay.